Hi everyone, so in this part we're going to see the properties of alkanes, chemical and physical properties. Before we look at this, I'm just going to correct this question which was on the isomers. So C5H12, so you should find all the possible ways of having the same molecule with different arrangement of the atoms but with the same molecular formula. So C5H12, one way is having all the carbons next to each other, so they are all in line. So that's the first one, so C5H12. Then we have the second one where I took the longest chain to be of 4 carbons, so carbon 1, 2, 3, 4. Then I did a branch, so I attached one last carbon, so the 5th carbon, I attached it to the 3rd carbon here. So let's say, so that's the 5th carbon, so 5 carbons, still 12 hydrogens, so C5H12. Okay, now if you look at this one, if you would want to attach the 5th carbon to this carbon here, actually if we count, like when we're counting carbon atoms, you could start any point in the chain. So in this case, so I could have this to be carbon 1, so 1, 2, 3, 4, or I could have this to be as carbon 1, so 1, 2, 3, 4, and then this would be the 5th carbon. Okay, so when I'm counting on the longest chain, you can start either way. There is nowhere that's stated that this has to be carbon 1 and this has to be 2nd carbon, so you can start any way you want. So if I start in this fashion, you see that this molecule and this molecule are the same because the 5th carbon here is attached to the 3rd carbon. So you'll see that here. The 5th carbon is attached to the 3rd carbon, and here the 5th carbon is attached to the 3rd carbon again. So which means that these two molecules, they are the same. So they are not isomers, they are the same molecules. Okay, so whichever way you start counting, you have to check that it's not the same molecule. The molecule is not repeating itself. So these two, they are the same molecule. So you include either this one, either A, or you include B. Don't include both of them because both of them, they are the same molecules. Okay, and then you have the 3rd isomer. So I have the 3rd isomer here. So carbon 1, 2, 3, or I can count like that, 1, 2, 3, and then 4 and 5 on top. Okay, so still 5 carbon, so C5H12. So this one has the longest chain. The longest chain has 5. This one, longest chain, has 4, and this one, the longest chain, has 3. So I'm just playing around with the number of carbons in the longest chain for me to get the isomers. Okay, and then you fill in the hydrogen. So there's 3 isomers for C5H12. So just make sure you have this noted in your copybook. Now let's see physical properties of alkanes. So alkanes have very similar physical properties, like within like all the alkanes, they are insoluble in water. All of them are insoluble in water. All of them are less dense in water, which means that they will float, and they are all flammable, which means that they are good fuels. They will catch fire easily. But the physical properties are going to change as the molecular size increases, which means that so you see here the molecular size will increase, which means that as the molecular size is increasing, the physical properties will change slightly. Okay, they will still all be flammable, they will still all be insoluble in water, they will still float on water, but there's going to be a gradual increase or a gradual decrease as we're going, as we're increasing the molecular size. So as the molecule is getting bigger, the physical properties will change. So let's see melting point and boiling point, viscosity and flammability. So boiling point, actually as we increase the molecular size, the boiling point is going to get increased. Okay, so actually what happens is that let's say CH4, so CH4, let's represent CH4, so let's say that's CH4, so that would be C2H5, let's say. Okay, so that's C2H5, that's C3H8, C4H10, C5H12. Okay, let's say these are the molecules, like the region, like the area they occupy. Okay, so if you look at CH4, like between CH4 molecules, let's say these are the CH4 molecules, between them there's going to be some interactions. It is these interactions that will cause the boiling point. Okay, that is good. These are the interactions that we need to break. We need to break these interactions so that to boil the methane. Okay, now if we look at ethane now, so let's say that's another ethane. Okay, so let's say these are ethane molecules, and when you look at it, you'll see there's more area of contact because the molecule gets bigger. There is more area of contact here, so there is more interactions that we need to break. So which means that you'll need to supply more energy to break the forces of attraction between the molecules. So as it gets bigger, as the molecules get bigger, there is more interactions between the molecules, which means that you need to supply more energy to break the forces between the molecules, which means that the boiling point is going to increase. Okay, so because when you're boiling, you're actually breaking forces of attraction. So this is what you see here. So boiling point for ethane -88, propane -42, butane 0, pentane 36. So you see the boiling point increases when molecular size increases. Okay, this is what we see as we are increasing the molecular size of the alkanes, right? So I will let you fill in the molecular formula of all these because you're familiar with them. And now plot a graph of boiling point on y-axis and carbon atom on x-axis for the alkanes using information from the table. So it's from this table. So you'll have to plot number of carbons against boiling point. You can do that in your copybook. You can just draw a sketch of it. If you have graph paper, you can do it on graph paper, or you can sketch it in your copybook. So go ahead, do that, pause the video, and then you can check your answer. So this is what you should get when you plot the graph. So make sure you label the axis properly, number of carbon atoms, boiling point per degrees Celsius. I've chosen this scale because it allows me to have the values plot, like the graph is like big enough. And yeah, so now you'll need to join all the points using a straight line. So that's the line of best fit that I've chosen to draw. So I have one point which is on top of the line, and one point which is at the bottom of the line, and one which is almost nearly there, and one which is on the line. So that's a line of best fit. Now from the questions, it tells you use your graph to deduce the boiling point of hexane, show your workings. So show your workings, you will have to show on the graph how you got the boiling point for hexane. So for hexane you will need to extrapolate, which means that you will need to figure out what boiling point matches carbon number 6. Let me show that using straight lines. So if you do that properly, you're going to have a line that goes up here, and that is going to meet the y-axis over here. So if I read that, so that's going to be, so if this is 75, that would be 80. Usually this is 85, so in the center, both of them, so it's going to be 82.5. okay, so here use your graph. So I would say 82.5 degrees Celsius. Now a hydrocarbon has formula C8H16. Explain why this is not an alkane. Now if you remember, alkanes have general formula CnH2n plus 2. If you look at this formula, it's C8H16. So if n is equal to 8, then 2n plus 2, that should be equal to 18, which means that for this to be an alkane, it should have formula C8H18. So then you can write the answer. So why it is not an alkene? Because the formula of the hydrocarbon does not match the general formula of an alkane, which is CnH2n plus 2. So it should have been C8H18 for it to be an alkane. Okay? So that's the answer for that question. Make sure that you write the subscript, the numbers in subscript. Okay? So that's the answer. So what does the graph show about the boiling point of alkanes? So you can clearly see that the graph shows that the boiling point is going to increase as the number of carbon atoms is going to increase. So as carbon atom increases, boiling point of the alkane is going to be higher. So from this, you can predict what would be the boiling point of any alkane. There is no need for you to memorize the boiling points of these alkanes, but you can be given a series of boiling points and tell you and the examiner could ask you, okay, predict the boiling point of this alkane. Okay, so what does it show? It shows that as number of carbon increases, the boiling point is going to increase. Now, depending on the number of carbons, because the boiling point increases, the state of matter of the alkane is going to be different at room temperature. So if you look at alkanes with low number of carbons, so from carbon 1 to 4 at room temperature, they are usually gases. So if you look at from 1 to 4, so if you look at these, so these are the low number of carbons. That would be the room temperature over here. So that's a room temperature. So anything that has boiling point below room temperature is going to be a gas. So from this we can see that carbon number 1 to 4, they're going to be gases at room temperature. From 5 to 16, they are liquids at room temperature. And greater than 17, they are solids at room temperature. Okay, depending on the boiling point, because boiling point keeps on increasing. So so these are the answers. Now viscosity. As molecular size increase, alkanes become more viscous. Viscous means is the ability that we have to pour it easily. For example, we could say that water has a low viscosity and honey has a high viscosity. So honey is more difficult to pour than water. It takes longer. So as molecular size increases, it becomes more viscous. It becomes more difficult to pour. Of course, it's going to impact because it's getting heavier. The alkane is getting heavier and boiling point is increasing. So definitely it's going to become more difficult to pour. Flammability. So as the molecular size increases, percentage of carbon increases. So we have more carbon in the molecule. right? And because there's more carbon, it becomes more difficult for you to burn it, because the flame has to reach the carbon for it to react with it to give carbon dioxide and water. So because there's more carbon, so you need to have more oxygen in, okay? And as we're increasing the chain, so we need more oxygen, so there is greater tendency for the alkane to burn while undergoing incomplete combustion, because you need more oxygen for it to burn completely. So when the alkanes become heavier, so the flame becomes orange and more smoky. Smoky flame means there is incomplete combustion. So there's going to be soot that is going to be produced. So the black thing that is produced, that's soot, that's carbon. Okay, so it's carbon, then you can have carbon monoxide, which is also produced. Okay, so these are the physical properties of alkanes. The next video will look at chemical properties.